Hello everyone, I'm Andre, and in this video I'll be presenting my project WaterAid. So let's get started with a short presentation of the product. So what problem are we faced with? Well, I'm sure we all heard the words water pollution on the news at some point. Every now and then we get some new statistics on marine species nearing extinction. Oil spills of hundreds of gallons and the occasional footage of plastic waste forming literal islands in the ocean. 1 in 32 people die every year from disease contracted through using and drinking unsanitary water, and as more of the 2.5% of drinkable water we pollute, the more this figure is doomed to grow. 2.4 billion kilograms of waste ends up in oceans every year, and we are all responsible for that figure, from your neighbor that seems to always be missing the bin, to large corporations washing away their waste. We are all in this together. This is truly one of the greatest challenges humanity faces today, cleaning up our garbage that we dumped in waters. So, what can be done? Well, individual action and responsibility is needed to help stop this pollution, but it is essential to identify pollution at its source by monitoring water quality. This allows authorities and companies to mobilize and take appropriate action to eliminate this pollution, be it through applying sanctions or education. The solution is ambient water quality monitoring, but even some developed countries can't afford this. Proprietary technologies, high operation and development costs, and intensive maintenance make it very difficult to monitor water quality effectively. This is where WaterAid comes in. WaterAid is a flexible, low-cost and effective water quality monitor that aims to change the way water quality is measured. The device is equipped with a multitude of sensors including water temperature, pH and turbidity, which provide real-time insight into the overall water quality. The device is connected to the cloud via 3G, securely streaming the data live to a dashboard that can be viewed and shared. This allows critical data to be analyzed and modeled in seconds. Device parameters such as the interval of time at which sensor readings are sent to the cloud can be set remotely via the dashboard. This dramatically reduces the maintenance required for the devices. Equipped with a solar panel and efficiently written code, each device can function self-sufficiently in the field for months without the need of human intervention. Okay, enough talk. Let's see WaterAid in action. So, in personal mode, as previously mentioned, WaterAid can be carried around and placed in the water whenever the user wishes to take a sample. As we can see, the user presses the button and feedback is received through the LED ring. The user then puts the sensors into the water and keeps them submerged while the LED ring finishes its blue cycle. When this is done, it will light green, indicating that data is being sent to the cloud. And that is it. The data is now available in the dashboard. Great, so what about enterprise mode? Well, as previously mentioned, in enterprise mode, the device collects and sends data to the cloud at defined intervals of time, which can be changed through the dashboard. As we can see, the device is equipped with a solar panel and is currently running low power mode. This allows it to stay online without needing battery recharging for weeks or even months. The device goes into deep sleep between data reads to ensure its longevity and reduce its battery consumption. Great, so now let's move on with the dashboard. This is where all the data collected by all devices, be it one device or 100, is collated. The dashboard has two sections. The first, as we can see in the video, is the dashboard itself. This is where data from all devices is compiled, averaged and collated. As we can see, all the data is displayed on line graphs and cards. This allows us to have a quick look at the overall data collected by all devices. The second part of the dashboard experience is the device dashboard. This is where data specific to one device can be visualized. We can see the device's location where data was collected, together with graphs showing the data collected over time. We can also see the raw data, which is properties sent by the device to the cloud, such as its MA, and settings, which allows us to change properties such as the interval of time between telemetry sending. And that more or less sums up the project. Thanks a lot for watching, and I really hope you enjoyed the video.